You might think you're up to speed with AI and tech, then you read what's happening today and realize the future's already been rewritten while you were breakfasting. Picture this: big tech pouring cash into nuclear fusion, machines helping healthcare providers recover billions in lost revenue, AI agents being treated like employees, and scientists chilling their detectors to near absolute zero to possibly glimpse dark matter. It's not sci fi, it's what's going on right now. Let's unpack these developments, see what they mean, where they might lead, and what you absolutely need to know if you care about where tech is taking us. First up, there's a wave of investment reshaping the energy sector in response to AI's thirst for compute and power. A report says that big tech's growing demand for electricity is partially fueling a revival in nuclear fusion efforts across the US. Fusion is the holy grail of clean, almost limitless energy, combining, not splitting atoms to release vast power without the long-lasting radioactive waste of fission. Developers and private companies are increasingly getting backing, pushing through design obstacles that until recently seemed insurmountable. It's still experimental, no net energy gain yet that's commercially practical, but the race is real. The implication is that if fusion becomes viable, it could help power the data centers, AI training farms, and massive server clusters that modern society leans on. But there are engineering, safety, regulatory, and scale challenges that remain. Efficiency, cooling, materials, sustaining plasma, pipe, and cost all have to keep pace. This is as much a gamble on physics and materials science as it is a stake in charting the path for AI's infrastructure. Parallel to that, workforces are being transformed. A new report by the AI Workforce Consortium, which includes names like Microsoft, Google, SAP, Intel, and others, found that 78% of ICT roles now include some AI technical skills. Jobs that didn't used to need machine learning or prompt engineering, or at least the awareness of them, are now being written with those expectations. Meanwhile, human skills, communication, leadership, ethics, are also being flagged as vital for responsible tech adoption. They're not just side notes anymore. This suggests the next few years will see not just more automation or AI features, but widespread reskilling, job evolution, perhaps even role obsolescence for people who don't adapt. For students, professionals, even institutions, that means the pressure is on to update curricula, training programs, internal company structures. AI is no longer a niche, it's woven into nearly every tech job. In healthcare tech, Waystar has dropped some game-changing announcements. The company's advancing its AI-powered software for denial prevention and reimbursement recovery. What does that mean in real terms? Healthcare providers in the US lose tens of billions each year due to denied insurance claims and about uncompensated care, manual delays. Waystar is promising time savings over 90% in key steps, improving collections, automating parts of those manual cycles. That translates into stronger financial health for providers, more resources freed up for actual patient care rather than paperwork, and likely pressure on competitors and regulation to keep up. But with health data, compliance, privacy, patient safety all in the mix, scaling such AI systems without error or unintended bias will be a huge test. There's also an important story from Microsoft and Workday collaborating on agentic AI workers, or agents. They're pushing enterprise tools so companies can track, secure, and manage autonomous agents more like they manage human staff. Each agent built using Azure AI Foundry or Copilot Studio will have a verified identity via Microsoft's Entra Agent ID system. Permissions, roles, context all become more explicit. The implications are huge: operational transparency, auditability, responsibility when agents make decisions. On the flip side, this raises issues of accountability and oversight. Who is liable when an AI agent messes up, whether we truly treat them like software or like digital workers? Are we ready for that shift? In science land, Crocodile is doing experiments at near absolute zero temperature, superconducting detectors cooled to extreme lows. They're probing dark matter, that elusive stuff making up most of the universe's mass, yet invisible and nearly undetectable. Crocodile's new sensitivity is pushing the boundaries. Energy deposit measurements so small they were considered impossible before. They recorded some unexplained signals, not enough to claim discovery, but enough to narrow the parameter space where dark matter could be hiding. And that's a big deal in physics, ruling out possibilities, sharpening models. If they can improve directionality, that is, figuring out from which direction incoming signals come, and reduce background noise, we could be closer to confirming or denying decades-old theories. The ripple effects touch cosmology, particle physics, maybe even tech inspired by those discoveries in sensors or materials. Another angle, modernization of legacy systems. Rocket Software has been pushing COBOL modernization using generative AI and ARM-ready deployment. For many large institutions, banks, insurance companies, government bodies, COBOL is everywhere. Systems that run on COBOL are fragile, hard to maintain, often opaque. Rocket's approach tries to update or replace those systems without shutting them down, without massive risk or downtime. They're using generative AI tools to refactor, translate, optimize COBOL code aligned with newer architectures like ARM while preserving reliability. It's an example of tech not just chasing new, but making old things work better, safer, faster. Critical for finance, government, any institution that depends on decades-old software. There is also a signal in regulation and safety, particularly from OpenAI today. They announced more progress on age prediction systems, tools intended to help determine whether a user is under 18 so that their ChatGPT experience can be tailored with stronger safety protections, blocking graphic content, stricter policies when needed. They emphasize that when they cannot be confident in a user's age, they default to the more protective experience. This reflects a trend: more AI tools introducing safety fallbacks, more conservative defaults, acceptance of imperfect knowledge in favor of erring on side of protection. That brings benefits: better safety, fewer abuses, but also costs: false positives, privacy concerns, age verification, misuse, potential for overreach. When you pull all these threads together, you see a pattern. AI is increasingly moving from toy lab phase to baked-in infrastructure. It's shaping power systems, workforce demand, financial systems, healthcare, scientific discovery, and regulation. The tension is between pushing for capability and speed and managing risk, ethics, safety, oversight. Whoever builds fastest gains advantage, but whoever ignores trust and responsibility may face backlash, failure, or worse. If you take away one thing today, let it be this: the future isn't just about what AI can do, but how we build it, who controls it, who benefits, and who is harmed. The science we do now, the safeguards we build now, the norms we accept or reject now, that will define what kind of tech society we get. Thanks for sticking with me through this roundup. If any of these stories sparked questions, maybe on fusion powers viability or agentic AI regulation or dark matter detection, drop a comment, and I'll get you the sources, the debates, and deeper analysis. Until next update, keep thinking critically, keep watching closely, and don't let the future just happen to you. Help shape it.